we have a tricky one to finish the lesson off with, and it is something that doesn't have a GCF, clearly not a trinomial. Is it the difference of squares? Yes, it is. Is it the sum or difference of cubes? Yes, it is. It is two different strategies. Both of them work, and they're both going to give you the same answer, but that answer is going to look very different. And math does that. It's fun. So let's delve into the fun. Let's treat it like the difference of squares first. And I know you're saying, okay, well, yeah, that's the perfect square, but x to the sixth is also a perfect square, right? So here goes. Let's keep it the same color. This is really x cubed squared, right? Right. And this is 8 squared, which is really going to give me, well, x cubed plus 8 and x cubed minus 8. There we go. There's your difference of squares. Now, at this point, we have the sum of cubes and the difference of cubes. So we're going to take what we've learned and continue to apply it. And again, this is, let's write it in yellow so you can't see. That's 2 cubed is 8, and then of course 2 cubed again is 8 right there. And so that's going to help me as I process through this. Let's scroll this up just a little bit. There's that. All right, x cubed plus 2 cubed. That means I have an x and a 2. X squared, 2x, and 2 squared. Let's deal with signs. Same sign, opposite, always positive. Okay, we're going to do this one as well. X and 2. X squared, 2x, and 2 squared. Same sign. Opposite sign, always positive. This one's done. Now, you could look at that and say, well, maybe I can put some of these together and create an exponent, but you don't have the same factor twice, like x plus 2, x minus 2. These look alike, but they're different. Now, what we're going to do, if I can say it, because I just kind of stammered my way through that. Let's use purple. What we're going to do is treat this problem like the difference of cubes instead, and it's going to be a little bit different. So x to the sixth is really x squared cubed. Notice x squared cubed and x cubed squared, same thing. It's going to give you x to the sixth in either case. And this is 4 cubed, so minus 4 cubed. So we're going to follow that process with the a minus b situation with the formula, where we are going to apply where a is x squared and b is 4. So here goes. X squared and 4. X squared squared. We'll take care of that in a minute. X to the 4th. And 4x squared, and then 4 squared. There's a little bit of mess to clean up here. All right, same sign, opposite sign, always positive. Let's clean up a little bit more. X squared minus 4, and then x to the 4th plus 4x squared plus 16. There we go. And we'll continue to factor, and I hope you notice that this is the difference of 2 squares. So we're going to have x plus 2 and x minus 2. And then we're going to have this crazy thing here that you're tempted to factor, and I would love to tell you it doesn't factor. And in a previous video I said, now these factor, or I said, no, these don't factor unless there's a crazy thing going on. This is a crazy thing going on. This factors, okay? And how does it factor? We're not going to get into that, okay? We're not going to get into that at all, but I do want to point out that what you see in black right here is what you see in purple right here, all right? So notice, x plus 2, x minus 2, x plus 2, x minus 2. Everything's accounted for there, but this trinomial and this trinomial are the same as this trinomial. I could extend this video another hour by multiplying this. Let's switch colors. I could multiply this by this, and I would get this, and I have done it previously. So it does definitely work. Or I could factor this and get both of those. We're not going to go into that, but these are the same. And this one is done.